Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In this lecture, we will discuss about similarity of triangles. Now, in the last lecture, we discussed that two triangles are similar if their corresponding angles are equal. Corresponding angles are equal, right? We will use this word corresponding every time we write about angles or sides, right? The second thing was, and we wrote or, and we understood why or is written and is not written here. Corresponding sides are proportional, right? If any of these two conditions is met, then the two triangles are said to be similar, right? And this is an optional here, because the option is there because if the first condition is met, then the second one will automatically meet, okay? If corresponding angles are equal, then it will essentially be true that corresponding sides are proportional, right? You don't have to worry about this condition then. And if this condition is met, that the corresponding sides are proportional, then you don't have to worry about the first condition because it will automatically be true, okay? So this is what we discussed in the introduction part. Now we will discuss about very important theorem, that is basic proportionality theorem. This theorem is also known as Thales theorem, okay? Now, if I have got a triangle ABC, first we will understand about this theorem, then we will write the definition together, okay? Once you understand this theorem, then you yourself will be able to write the definition, okay? Let us take this line DE, okay? Now, this line DE is parallel to line BC. DE is parallel to BC, okay? And it cuts side AB at D and side AC at E, right? Now, I will use two things in this question. One, that if you have got two parallel lines, right, and let us say you take this base here, let's name it as PQ, right? If using the base PQ and between these two parallel lines you make a triangle PQR, and having the same base you make another triangle PQR dash, having the same base you make third triangle here, let us say PQR double dash, then the areas of triangle PQR will be equal to area of triangle PQR dash, and it will be equal to area of triangle PQR double dash. Why? Because all the three triangles have got same base. Base for all these is PQ, and the height will also be same for all these three triangles. Why? Because these are two parallel lines. If you drop a perpendicular from the vertex, any of these vertices, this length will be equal to this height h, will be equal to the gap between these two parallel lines, right? So, if this is h, this will also be h and this will also be h. So, base is same, height is same, so area is half into base into height. So, if base is same, height is same, the area will also be same, right? So, this is what we are going to use in this theorem. And another thing that we will use here is that let us say again these two lines are parallel, right? If you have a triangle like this, okay, and if you have got another triangle like this. Now, for these two triangles, the base is this. Let us say name it B. Okay. What is the height of this triangle? This triangle will have a height of this h, right? And what is the height of this triangle? This is again h. The point I am trying to make here is that this height or this altitude may be outside the triangle also. It is not necessarily inside the triangle, which happens in most of these acute angle triangles. Let us say if I drop a perpendicular here, this is your notion of height in a triangle and this is the base. Now, in these triangles, the height is outside the triangles. These are obtuse angle triangles that I have made, and in these height or the altitude is outside the triangle. So, you do not have to worry about it. It will work in the same way this height inside the triangle works. So, the area of these triangles is half into b into h for both these triangles, okay, and for this triangle also it is half into b into h, where h is height of this triangle and base of this triangle is b, right. So, these are the points that I wanted to make here. Now, what I want you to do is drop a perpendicular here and drop another perpendicular here. Okay, I am not going to write all these steps here. Okay, I just want you to understand the concept here. You join the points BE, join the points DC. So, I am not writing here join BE, join DC. You understand this and write it yourself. My effort will be to clear the concept of this theorem to you in brief, so that you can keep it in your mind or you can memorize it for the lifetime. And you can memorize a certain thing for the lifetime if you understand the concept. Okay. Let us name these points M, N, right. So, I want you to focus on this triangle here. If let us say talk about triangle ADE, okay, what will be area of triangle ADE? Let us denote it by area of triangle ADE. It will be equal to, if I consider AD as my base and ME as the altitude, then the area will be half into AD into ME, right, half into base into height. And if I consider AE as the base, so the area will be half into AE into, now this time the altitude will be DN, right. This is one thing that I wanted to tell you. Another thing, look at this triangle here, triangle DEB. For this triangle DEB, if I take DB as the base, what will be the height? Because the area is half into base DB into height. What is the height in this case? Now, in this triangle, the height, if you extend this line BD here, the height is EM, because from this vertex E, if you drop a perpendicular on this side DB, it will be outside the triangle, that is EM will be height for this triangle. So, you will write EM here, right. So, this is about area of triangle DEB. Now, let us look at another area. I will talk about area of triangle DEC. Okay. Now, in this triangle, if I take EC as my base, then what is the perpendicular that I can drop from this vertex? It will be DN, right. So, the area of triangle DEC is half into base EC into the altitude DN. DN works as the altitude for the triangle DEC when we are taking EC as the base. I hope you have understood, and I hope you have understood the concept by now. Now look at this. DE is parallel to BC, okay, and DE is the base for both triangle DEB and triangle DEC. So these two triangles, triangle DEB and DEC, are of the same base and same height, right? For these two triangles, if there are two triangles between two parallel lines with the same base, then these two triangles have equal area, right? Why? Because if the base is same and they are between two parallel lines, the height will necessarily be same. So two triangles with the same base and between two parallel lines have the same area, right? These parallel lines should also be same lines. We discussed about it here also, right? So now look at these. DE and BC are parallel lines and base is DE for both these triangles, right? And these are between two same parallel lines. So these two areas are equal. Hence what I can say is area of triangle DEB and DEC is equal. Area of triangle DEB is equal to area of triangle DEC, that is half into DB into EM is equal to half into EC into DN. So we will get a result from it. Half can be cancelled here, okay. So DB into EM is equal to EC into DN. Now another result that we can get is from this. So these areas are for the same triangle ADE. So these are equal. We already proved it. So half into AD into ME, half into AD into ME is equal to half into AE into DN, half into AE into DN, right? Now look at these ratios. EM is there, ME is there, DN is there, DN is there. So if I take their ratio, let us take the ratio as if I divide these two, let it be 1 and let it be 2. If I divide 2 by 1, it will give me AD upon DB, because ME will be cancelled, is equal to AE upon EC. In this, DN will get cancelled. So what is this result? AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. This result is the basic proportionality theorem or Thales theorem, which says if there is a line parallel to a line in a triangle cutting the other two lines at two different points, that is D and E, then this line will divide these two lines in equal ratios. As we have seen, AD by DB is equal to AE by EC. So if we have to write the exact definition here, we can say if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points right. We have drawn the line D. Which line did we draw? We drew the line DE in this case. So, if we can draw a line parallel to the a side of a triangle, if we draw a line DE parallel to side BC, cutting the two sides AB and AC at D and E respectively, then the other two sides are divided in the same ratio, as we saw there that AD by DB was equal to AE by EC, right. This was the triangle ABC and this was the line DE. So, if this was A, this was B and this was C and this was D, then A by B was equal to C by D, right. It divided the other two lines in the same ratio. This is about Thales theorem, or we also know it as BPT, that is basic proportionality theorem, right. Now, what are the results that we can obtain from it? Now, what we have obtained by now is AD by DB is equal to AE by EC, right. Now, I want you to add 1 on both the sides. If you add 1 here and add 1 on this side also. So, what will happen is, it will give you AD plus DB in the numerator here and DB in the denominator. Here I will have AE plus EC divided by EC. So, I will get a new result here. AD plus DB is AB and it is divided by DB, and AE plus EC is AC and divided by EC. If this was my first result, okay, let us say this is my result number 1. So, I have got another result here, result 2, that the ratio of this complete side AB and this portion DB is equal to the ratio of AC and this portion EC here. You look at the corresponding portions here, DB is corresponding to EC, right, AB is corresponding to AC. So, all these ratios are equal. Now, another result that we can prove from it is, using this first result, if I write the reciprocals of this, I can write DB upon AD is equal to EC upon AE. This is just the reciprocal of our first equation on both sides, right. We have taken the reciprocals. Okay. Now, if I add 1 on both sides, these are the reciprocals. Right. Now, if I add 1 on both sides, so numerator will be AD plus DB by AD now, AE plus EC by AE. This time the numerator here is AB, but in denominator if you see, we have got AD, and here AC and denominator we have got as AE. So, AB by AD is equal to AC by AE. What does this result show us? AB by AD. So, this AB by this portion now is equal to this complete side AC by this portion. Okay. So, what are the results that we have got? That these portions, if you mark them like this divided by this is equal to this divided by this, right. And if you take the complete sides AB and you divide it by any of these two portions, then on the other side you can take AC and the corresponding portion. Okay. So, if I take two triangles here again, if I take a triangle here again and draw a parallel line, okay, if I name it as A, name this as B, this is C, this is D. The only thing I am given is that this line is parallel to this line, then I can say A by B is equal to C by D, right. I can also say that A plus B divided by B is equal to C plus D divided by D, right. How did I get this result? By adding 1 on both sides, right. So, this is how we obtained those results, and the third result I just took the reciprocal and then added 1 on both sides. So, this was about basic proportionality theorem. Now, we can also discuss the converse of basic proportionality theorem. What is the converse? Now, the basic proportionality theorem was that if you have a parallel line intersecting the other two lines, right, then it will divide the other two sides in the same ratio. Now, if you are given that the other two sides are divided in the same ratio by a line, right, then it will be parallel to the third side. For example, if you are given that this is a line DE which divides AB and AC in such a way that AD by DB is equal to AE by EC. Now, this time this is given, right. Now, we need to prove that DE is parallel to BC. So, this is converse of BPT, basic proportionality theorem, that if there is a line which divides the two sides of a triangle in same ratio, that is AD by DB equal to AE by EC in this case, then this line will be parallel to the third side. And how can we prove it? We can prove it by contradiction method. We can assume that DE is not parallel to BC. Okay. So, if DE is not parallel to BC, there should be some other side which is parallel to BC. Let us say this is the side. DE dash is parallel to BC. Okay. I am just telling you this in brief, right. You can write all the steps yourself. If once you understand this, you do not have to memorize the steps even. Okay. So, if DE is not parallel, right, we are proving it by contradiction, then there should be some other side which should be parallel. Let us say it is DE dash. Now, if DE dash is parallel to BC, by basic proportionality theorem, we can say that AD by DB is equal to AE dash by E dash C, right. We can apply basic proportionality theorem on it, right. But we are given, this is given, right, but we are given, but AD by DB is equal to AE by EC, right. So, this is equal to this, hence these two are also equal. So, AE dash by E dash C is equal to AE by EC. Now, look at this. If you add 1 on both sides, the left hand side will become AE dash plus E dash C by E dash C, and the right hand side will become AE plus EC by EC. Now, what is this AE dash plus E dash C? This is sum of these two portions which will make it AC. So, AC by E dash C is equal to, this is also AC by EC. Hence, we can say E dash C is equal to EC. And how can these two portions be equal? E dash C and EC can only be equal if E dash overlaps E. That is, E dash and E are same points. These are not two different points. Hence, our assumption was wrong. So by contradiction we can say DE is parallel to BC. Okay. So this was given this time, the ratio, and we proved that this line will be parallel to the third side. So this is the converse of BPT, converse of basic proportionality theorem, right? Now let us look at this question here. I prepared this question for you. If a line intersects sides AB and AC, let us say this is the triangle. Let us draw a different triangle here, ABC, okay, at D and E. So let us say this is the line and is parallel to BC. So this is parallel to BC. Prove that AD by AB is equal to AE by EC. Now we have already proved this result, AD by AB equal to AE by EC. So if you just take the reciprocal of this third result, this is same as this, right? And how did we arrive at the third result? I already discussed in detail, right? By taking the reciprocal of the result that we got from Thales theorem and then adding 1 on both sides. Okay. So this, now after you know basic proportionality theorem, these results are just about manipulating the ratios, right? Take the reciprocals, keep adding 1 on both sides, right? You can keep on working on the ratios to get the various results. So this question is already done. Now let us look at this. ABCD is a trapezium with AB parallel to DC. So these two lines are parallel. E and F are points on non-parallel sides AD and BC respectively. Yes, such that EF is parallel to AB. Now see, if EF is parallel to AB, AB is parallel to DC, EF is parallel to AB, then we can say EF is parallel to DC also. So all the three lines are parallel to each other. Okay. Now we need to show that AE by ED, AE by ED is equal to BF by FC, right? I need to talk about the ratios of these lengths, right? So what in a trapezium, what we can do is, we will do a little construction here, construction, right? So you need to write to prove first, to prove, this is what we need to prove, right? And this is given. So all these steps you write yourself. I am just giving you the idea of the concepts to solve the questions, okay? So the construction that we are going to do here is, we will join B and D, join D and B, okay. Now once you join D and B, why did I join this? Because this will convert this trapezium into two different triangles, right? And for the triangles we have done the basic proportionality theorem. So I am going to utilize that knowledge to solve this, to prove this result, right? Now look at the triangle ADB. In triangle ADB, if I name it M, EM is parallel to AB, right? What does it tell me? That if EM is parallel to this side AB, then it will divide the side DA and DB in same ratios. So what I can say from here is that DE by AE is equal to DM by MB. Now you cannot say that DE by AE is equal to MB by DM, then it will be wrong. You need to take care of the correspondence, that if I am writing DE here in the numerator, then I need to write DM on the right hand side in the numerator, right? So this is the correspondence that we were talking about in the introduction, right. So, this is the result we have got using Thales theorem or BPT, basic proportionality theorem, right. Now, we have got another triangle. In triangle BDC, MF is parallel to DC, which gives me my another result, that BM by MD is equal to BF by FC, right, using Thales theorem or BPT, right. So, now this is my result number 2. Always keep in mind the result that you want to prove. You want to prove AE by ED is equal to BF by FC. Now, AE by ED, if we reverse this, we will get AE by ED. So, reciprocal of 1 is, will give me AE by ED equals BM by MD. MB or BM, it is one and the same length. You call this length BM or MB, it is same. So, I will use these interchangeably, right. So, here I have written MB and here I have written BM. So, it is one and the same thing. Now, look at these two, this and this. BM by MD is equal to BF by FC, and here BM by MD is equal to AE by ED. So, comparing 2 and 3, I can say BF by FC is equal to AE by ED, and this was the result that we were looking forward to prove. BF by FC is equal to AE by ED. Alright. So, this is how we will use basic proportionality theorem to solve various questions.